Okay, so in this video here, we definitely have more of a challenging type of algebra problem. And to be honest, you could actually guess and check to do this problem. But the whole goal of doing this problem here is that we want to be able to set up a system of equations. That way we can get the answer every single time without guessing and checking. And that way, if the numbers become more complex, we will be able to do the problem no matter what. So it says the following here. It says, consider a two-digit integer where the total of its digits equals 12. If you swap the digits, or in other words, you reverse them, the resulting number is 36 less than the original number. What is this two-digit integer? So you have two unknowns here, right? You have a two-digit integer, meaning you don't know the ones digit and you don't know the twos digit. So I'm going to end up setting up a system of equations here. And so what I'm going to say here, I'm going to say that x is equal to my ones digit. Okay. And I'll say that y is equal to my tens digit. All right. And again, it doesn't matter which one you call which, but I'm calling x my ones digit and y will be my tens digit. And so the first equation is going to be pretty straightforward. We know that when we add up the digits, it's going to be 12. So all I have to say here is x plus y will be equal to 12, okay? And then from here, the second equation is not so obvious because in order to create the second equation, you have to think about how can I represent this number in terms of x and y? In other words, how can I come up with an expression to represent any two-digit integer? So for example, let's say we're working with 57, okay? Just picking the number 57. How can I represent that using x and y? Okay, so in other words, again, how can I come up with an expression to represent that number? Well, we know that the ones digit can be represented with 1 and the tens digit can be represented with 10. And so this may or may not be obvious, but you could actually create an expression the following way. You could say x or 1x plus 10y. And that will give us that two-digit integer. So for example, I know that my ones digit here is going to be 7 and my tens digit is going to be 5. So when I plug in 7 into x, I get 7 here. And then when I plug in 5 into my y, I get 50. And we know that 7 plus 50 will give you 57. And you can try this with any two-digit integer. It will work. So again, let's try 61, picking a random number. If I plug in my ones digit right here, 1, I plug that into x, I get 1. And then I plug in 6 into my y, I get 60. 1 plus 60, I get 61. It will work every single time, okay? So that's half the battle. I now know how to represent the number in terms of x and y, but I don't have a second equation yet. I only have that expression. So think about what you need to do here. We know that when we reverse the digits, the number becomes 36 less than the original number. So in other words, if I set this equal to the number that's going to be reversed, and how do I represent that number if I were to reverse the digits? Well, again, your ones digit and your tens digit are going to switch places. So in other words, I can represent that as 10x plus y. And again, you can try that out. You know, if you reverse the number 57, you're going to get 75. Okay, so if I plug in this original right here into this statement right here, I should get 75. So again, my ones digit there is going to be 7. Okay, see that right here. If I plug that into x, I'm going to get 70. And then I know that my tens digit is going to be 5. If I plug that into y, I get 5. So when I end up with 70 plus 5, I get 75. It works. It gives me the reverse of that original number, right? But then we know that, okay, this is not equal here because essentially, right, this is the original number and this is going to be the original number reversed, meaning they're not going to be equal. But I could make them equal by taking this number right here, right, the reverse number, and adding 36 to it. Because we know that it's going to be 36 less. So if I want to set it equal to the original number, I'll have to add 36 here. Okay? And now you're good to go. Okay? So now you have a system of equations. You can go ahead and solve for x and y, and then we'll get our number. So I would use substitution here. So I'm going to take equation 1. So again, equation 1 and equation 2. And I'm going to go ahead and use substitution. So I have to rearrange equation 1. So I'm going to go ahead and rewrite it as y equal to 12 minus x. Okay? And then I look at equation 2, and wherever I see a y, I have to plug in 12 minus x, okay? So here we go. We have x plus 10. Here's a y. I'm going to plug in 12 minus x, okay, and then close it. And then I have this equal to 10x plus, here's another y. I'm going to put 12 minus x. So 12 minus x, and then plus 36, okay? And so from here, we want to clean it up. Here I'll get x and then plus 120. Again, you have to take the 10 and distribute, right? And then negative 10x equal to 10x plus 12 minus x plus 36, right? Let's go ahead and scroll down. That way we have room. And now from here, we just want to go ahead and combine like terms, and then we'll solve for x. Okay, so cleaning this up, I'll have x and then negative 10x. That will give me negative 9x. Plus 120 equal to, I have like terms here and also here and here. Okay, so 10x minus x, that will give me 9x. And then 12 plus 36 will give me 48, so plus 48. Let's move the x variable over to the left-hand side and then our constants over to the right-hand side and see what we get. So to do that, I do negative 9x here, negative 9x here, right? This will cancel. And then negative 120 and negative 120. This will cancel here. So going ahead and scrolling down a little bit further, I will get negative 18x. So negative 18x equal to 48 minus 120. That will give me negative 72. So negative 72. And then when you divide by negative 18 here, you get x is equal to positive 4. So x is equal to positive 4. Meaning the ones digit of my number here is going to be 4. Now I have to get the tens digit. So this is the easy part. Now I go back up to the original equations that I got, and I can see that I can use either equation 1 or 2. It doesn't matter. You're going to get the same answer regardless, so pick the easier of the two. I'll go ahead and pick equation 1, and I can actually use this equation right here that we rearranged, okay? So all I have to do now is do 12 minus x, or in other words, 12 minus 4, because that's what I got for x. So again, for x, we got 4. So if I do 12 minus 4, I get 8. So y is equal to 8. There's my tens digit, right? So putting it all together, my tens digit is going to be 8. My ones digit is going to be 4. My number here is 84, okay? And so if I reverse those digits, I get 48, okay? And you can easily see here, if I do 48 plus 36, I get 84. Or in other words, if I do 84 minus 36, I get 48, right? And so again, that satisfies the statement saying that if I reverse the digits, it's going to be 36 less than the original number, right? So our two-digit integer here is going to be 84, okay? And so again, I do understand that you can solve this problem by guessing and checking. But the whole purpose of doing this problem here is we want to be able to get an equation, or in other words, a system of equations, so that we can get the answer every single time, even if we start getting into numbers that are more challenging, or perhaps a word problem that is a little bit more vague, and you're not going to be able to guess and check on it. You're going to have to use an equation. Well, now you know how, okay? So that is it. I hope that you gained something from the video. I hope that you learned something. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.